This video contains information to know how two triangles are similar or congruent. Depending on the side-angle relationship, certain information is needed. We all will be using the angle-angle, side-side-side, and side-angle-side theorems to prove that a pair of triangles are similar. In this example, we have a pair of congruent triangles. Congruence occurs the triangles have the same shape and size. Triangle DEF is a reflection of triangle CBA. Segment AB is congruent to segment FE. Segment BC is congruent to segment ED, and segment AC is congruent to segment FD. This is one of the rigid transformations a shape can go through. Rigid transformations are reflections, rotations, and translations. The shapes do not change in size or shape. So triangle ABC and triangle FED mirrors each other. Now, if we were to have one triangle smaller than the other, we would be looking at similarities. According to angle-angle or AA rule, if we have at least two pairs of congruent corresponding angles, the triangles must be similar. Angle BAC is congruent to angle EFD. Angle ABC is congruent to angle FED. Then angle BCA is congruent to angle EDF. For example, if measurements were given for two angles, then we could figure out the measurements of the third angle, because we know that the sum of three interior angles of a triangle equals 180. We'll subtract 180 from the sum of 76 and 56 to get angle C and angle D, which equals 48. We could also use side-side rule for triangle similarities using the same pair of triangles. Side-side-side states that if the three sides of one triangle are respectively proportional to the three sides of another triangle, then they are similar. They are just scaled up or down versions of each other. This is called dilation. Dilation is another type of rigid transformation. The triangles are the same shape but resized by having a scale factor. The scale factor is the ratio to produce the dilated shape by dividing corresponding sides. In this example, the lengths of the sides of each triangle are given. Triangle DEF is scaled down version of triangle CBE. To calculate the ratio, you divide the dimension of new shape over original. So EF over BA equals 2 over 4. ED over BC equals 4/8. DF over CA equals 10 over 20. Each ratio is 0.5. The lengths of the sides were reduced by 0.5 or by 1.5. In side-angle side, we use this rule to prove that the triangles are congruent. If two sides and the included angle of one triangle are equal to two sides and its angle of another triangle, then they are congruent. Here, segment AB is equal to segment FE. Segment AC is equal to segment FD. Angle A is equal to angle F. So triangle ABC is congruent to triangle FED.